hello, my Ninja Warriors. Welcome to yet another power-packed live session where we are going to start with a brand new chapter that is going to be integration. If I'm audible and visible with the brand new setup of mine, please let me know in the comment section. Hi Kushmohit, good evening. Hi Yogesh, how are you all? I am super duper happy, super duper excited to share this news with you all that I now have my own studio setup and I can take as many classes as possible as you want or as much I want, okay? So just confirm one thing that ma'am, yes, you are absolutely audible and absolutely visible, okay? Just confirm once, ma'am, you're audible, ma'am, you're visible. Everything is fine and we can start with today's session. Hi Mandar, how are you? Room tour needed, ma'am. Thank you, Mandar, thank you. Yes. So I guess Mandar, this explains that I was busy in setting up my studio. Yes, ABCD, all right. Okay. All right. So we'll start with integration, basics of integration. And you know that in physics also, this integration basics will be required to you, right? So this session is going to be absolutely helpful for your mathematics, but it is going to be helpful for your physics as well. So today's session, I think everybody should attend till the very end, okay? And I can see Shriraj, hi Shriraj, how are you? Are you new to the channel? Because I am seeing you for the very first time on this channel. Okay, so let's start with the integration till you understand integration. Okay, integration. Yes. All right. Perfect. Okay, so integration. Now I have taken a lot of sessions on differentiation. Yes. Okay, so integration is nothing but the opposite process of differentiation. Okay. And another word of integration, you can also call it as antiderivative. Antiderivative. Okay. Antiderivative is another word for integration. Okay. That means differentiation and integration are opposite process. Okay. Thickness should be more. Okay. Yes, this is better kya? Okay. Let me check. This is what? Yeah, I think this one is good. Oops. No, not this. This one, but with thicker. Okay. Yeah. So integration, it is also known as antiderivative. Okay. So suppose I write that g dash x is equals to f of x. Okay. So derivative of g, suppose derivative of g is fx, that means you can call it as d by dx of gx is your f of x. If you are writing like this, that means this implies integration of fx with respect to dx will give you gx plus c. Okay, understand that what is happening over here. If you differentiate g, you will get f. And mind it, it is with respect to x. Okay, differentiate g with respect to x, you get f. But if you integrate f with respect to x, you get g. So now you are getting antiderivative, opposite process, everything. Okay. All right. Yes. Hi Ramani. How are you? All right. Here fx is called as integrand. Okay. So in integration, whatever you are integrating, you are going to call this as integrand. What will you call it? Integrand. Okay. This is your integrand. Okay. X. What is x? The variable with respect to which you are differentiating. So x will be variable of integration. Variable of integration. And what is this? C is the constant of integration. Constant of integration, my dear students. Okay. All right. Clear? I guess that the process is clear. And now we can dive directly into some basic standard functions of integration, right? So basic fundamental formula of integration, right? So fundamental formula of integration. Okay, fundamental formula of integration. Cool? Perfect. Okay, so the very first formula I hope that you all are aware with is integration of x raised to power n with respect to dx. Can anybody tell me what would be the final answer of this? Like, what would be the formula for this? So this is going to be x raised to power n plus 1 upon n plus 1 plus constant of integration. Okay, this is okay. So x raised to power n integration is what? X raised to power n plus 1 upon n plus 1. Clear? First formula, I hope that this is clear. Now the second formula is of the sigma male. Do you know what is sigma male? Are you aware of the sigma male? Sigma male means which doesn't get affected or which doesn't get excited. Okay. So e raised to power x is that sigma male. If you differentiate e raised to power x, you will get e raised to power x. If you integrate e raised to power x, you will get e raised to power x. That means e raised to power x doesn't get changed while on integration or differentiation. Okay? Yes? Cool? So e raised to power x. Now third, integration of 1 upon x dx. So understand, in this first formula, n cannot be equals to minus 1. You cannot, this formula is invalid for n equals to minus 1, because the moment n is minus 1, then the formula will be this, 1 by x. Integration of 1 by x will be log of mod of x plus c. Do you remember derivative of log x was what? Derivative of log x was 1 by x. That is why integration of 1 by x is log of x. But can you see mod over here? Because log cannot have negative values. Log cannot have negative values. So while integration, we have to understand that we have to keep a full-fledged mod over here. Now, fourth formula, okay. Fourth formula says a raised to power x integration, again with respect to dx, correct? So if you have to integrate a raised to power x, you will get a raised to power x log of a plus c. This is your formula, a raised to power x upon log a plus c. Fifth formula of integration is cos x, integral of cos x, and sixth is integral of sin x. Okay. Integral of cos x, who is going to tell me? Integral of cos x. So integral of cos x is sin x and integration of sin x is minus cos x. Okay, now these 5 and 6 might create a confusion. So I am here so that you don't have any confusion, right? Just understand. What is derivative of sin x? Derivative of sin x is cos x. So integration of cos x is sin x. Are you getting this point? Now what is derivative of cos x? So derivative of cos x is minus sin x. So that is why integration of sin x is minus cos x. Okay. So sometimes it might confuse you that, oh, because it is opposite. The signs are opposite while talking about the derivative. Because in differentiation, the derivative of sin x is plus cos x and derivative of cos x is minus sin x. So this is reverse thing is happening over here. Don't worry. We'll be solving problems, we'll be doing some problems as well. Okay. Now some more formula of integration I would like to tell you, which is integration of sec square x. Integration of sec square x. Can anybody tell me? Is anybody able to remember it? Integration of sec square x is tan x plus c. Okay, tan x plus c. Then integration of cosec square x with respect to dx. This will be minus cot x. Minus cot x plus c, guys. Then sec x tan x integration. Sec x tan x integration will be what? Tell me. This is going to be sec x. Sec x plus c. So, see, this is the reverse process we are doing. You understand? Derivative of tan x is sec square x. Derivative of sec x is sec x tan x. Derivative of cot x is minus cos x square x. Hence, this explanation, right? We are not doing anything which is new. We are just writing the opposite of differentiation till now. Yes, you're getting it? Alright, then we are having integration of cosec x, cot x. So, cosec x, cot x dx. Can anybody tell me the integration of this? Minus cosec x, guys, minus cosec x plus c. Okay, till now any confusion? Yes, Tarun, I am also super duper happy. Super studio setup. Oh. I know. It will like now I'll be doing some other things also. Like there is some reflection I can see which is right here. So I'll be like gradually polishing the studio setup. Okay. All right. Now, yes. Now the question time. Are we ready for the questions? Formulas are done. Are we ready for the questions? Tell me. Integral of 1 upon x root x with respect to dx. Can anybody tell me? Yes. Tell me. Are you doing it? Shall I give you the options? Shall I give you the options? Okay, no options. Give a setup tour, ma'am. Sure, Mandar. Not on this channel, but yeah, I can give it on my Instagram. And I'll post on my Telegram. Make sure that you're subscribed to my Telegram channel, okay? Alright, dx upon x root x, correct? So let's integrate. First of all, what is this? This is actually dx upon x power half. And eventually it is going to be dx upon x power 3 by 2, correct? So x raised to power minus 3 by 2 dx integration. Okay. Now, if you just want to integrate it, you know that integral of x raised to power n with respect to dx is, ma'am, x raised to power n plus 1 upon n plus 1. This is the formula which we are going to use, right? So, this is going to give you x raised to power minus 3 by 2 plus 1 upon minus 3 by 2 plus 1 plus constant of integration. If you forget to add constant of integration, it will not be good for your school or university examination, PUC boards, right? It is not good if you forget this C. But if you're talking about KCET, don't worry about it, okay? Minus 3 by 2 plus 1 is what? So, x raised to power minus half upon, this is also minus half plus C, correct? So, this is 1 upon root x and this minus half is minus 2 actually. So, this is going to become, hold on, this is going to become minus 2 by root x plus c would be the final answer. Are you getting the same answer as me? Nobody is replying. Are you not able to solve it on time? Minus 3 by 2 plus 1 is minus half upon minus half. So, this 2 will go over here. This is 2 by root x and a negative sign. This is the final answer. Yes, give me a big thumbs up if you are like cool about this question, if you have understood this question, right? Shall I give you the next problem? Are we up for the next problem? Yes, in the chat box. Are we up for the next problem? Okay, let me give you the next problem, which is cos square x by 2 minus sine square x by 2 integration with respect to dx. Okay, see, majority of the times, whenever you see any integration question, it will hardly require integration skills. Majority of the time, it will require the simplification skills, my dear students. So right now, you don't have to integrate it. You just have to simplify it. Do you know the formula? Cos square theta minus sin square theta is cos 2 theta. So here cos square x by 2 minus sin square x by 2 will be cos 2 times x by 2 dx integration. And this is going to become cos of x dx integration. Now integration of cos x, come on, everybody knows this. Integration of cos x is sin x plus the constant of integration. Yes? Alright, easy peasy lemon squeezy. Alright, are we ready for another question also? Okay, now rather than another question, I would like to introduce substitution method. Okay, substitution method is something which is like most frequently used, most frequently asked method in your KCET examination, in your PUC examination as well. Substitution is something every now and then, here and there, you will find a problem from substitution, right? So we'll talk about integration by substitution. Integration by substitution. Integration by substitution. Okay, are we ready for it? All right. So suppose if you get this thing, do you remember the chain rule? Do you remember the chain rule? Hold on. Chain rule. So chain rule is f of g of x. Okay, so if you want to differentiate this, what will you get? Tell me. Ma'am, you will get f dash g of x and you will get g dash x. Correct? Yes. F dash g of x, then g dash x. So just the reverse thing is going to be happen. If you have to integrate the right hand side, which is f dash g of x, g dash x with respect to dx. Okay, let's integrate this. Okay, hold on. Let's integrate this. Okay, blue color or this color is also fine. Yeah. So what I'll be doing is I'll be taking gx is equals to t, substituting gx equals to t. The moment I substitute gx equals to t, what I'll be getting is g dash x dx is equals to dt. I am differentiating both sides with respect to x on the left hand side, with respect to t on the right hand side. So g dash x dx will be replaced by dt and g of x will be replaced by, so this is f dash t integration. So integration of f dash is what? F. Integration of f dash is what? F. So this is f of t plus c. Now what is t? What is t? Go back. What is t? What is t? So f of g of x plus c. Did you get it? Okay. So it is very simple. If you differentiate this, you will get this. So if you have to integrate this, finally you should get f of g of x, which you are already getting. Understanding my point? Okay, integration by substitution. I hope the concept is clear. Now we'll be solving some problems, a couple of problems. Okay, are we ready for the problems? Because mathematics and moreover integration is all about learning the technique and then solving tons and tons of problems. Okay, all right. So now let's start. Integral of ln x square upon x with respect to dx. And the options are option A. Okay, till the time you solve this, I'll write the options for you. Option A. Option B is log x whole cube by 3 plus c. Option C, is x log x and option D is x log x whole square plus c. Okay. Yasin is saying so much hard this chapter. Don't worry, Yasin. Just follow the lectures. You'll be like, the chapter is actually hard when you don't learn it properly. Once you learn it properly, you start having fun and then the chapter becomes so easy. So you'll find a lot of students who will be like, integration, I love integration. There will be a lot of students who will be like, I don't like integration. I just find it very tough. Okay, so it depends about your practice. You practice, you understand, learn the technique, apply it, you'll be feeling very good. Today we are doing that, okay? So let's start. Now, substitution, as I told you. So what I'll be doing is, I'll be putting, see, majority of the questions will be done by substitution, understand, especially for KCET and your boards, okay? So now log x, there are two options. I have like limited options. Either ln x I will put it as t, or 1 by x I will put it as t. So obviously first option, let's see if ln x, if I put it as t, it is working out for me or not. Just hit and try. If it will not work out, we'll try something else. We'll think about something else. So log f x. Now derivative of log x is 1 upon x dx equals to dt. Now see, 1 upon x dx will be replaced by dt. So your final answer will be what? See, if you replace everything with respect to t, so log x is t, so this is t square. Dx upon x is your dt, correct? So this is going to become t square, so t cube by 3 plus c. And t, what is t? ln x whole cube by 3 plus constant. ln x whole cube. Oh my goodness. Kush Mohit, what happened? Option B is the correct one. What happened, Kush Mohit? No, I'm disappointed, Kush Mohit. This is such a basic question. What error did you do? Or you just did the guesswork? Don't tell me you just guessed it without even solving it. Huh? Don't do it. Don't do it. Okay. Anyway. Alright. So now, see, the vibe is very different. Now, when I teach on smart board, I feel my energy levels are very different. And when I sit and teach, even I don't like that approach, okay? Chalo. Now, let's start with the next question. Are we ready for the next? Okay. So, again, x cube sine of x power 4 dx. Okay. Options. Till the time you solve it, I'll write the options, okay? Sine x power 4 by x plus c. Option B, sine minus cos x power 4 upon 4 plus c. Option C and option D. Let's see. Sin x power 4 by 4 plus c and minus x cos x. Let us see. How many of you are able to do it? Okay. Now, what should I substitute t? The question is the same. Like, what should I substitute t? What do you think I should substitute t? Tell me quickly in the chat box. Sine or just x power 4? What do you think I should substitute to t? Just tell me. I think x raised to power 4, if I substitute to t, it will become 4x cube dx is equals to dt. Right? So, x cube dx, can you see this x cube and dx will become dt by 4. Yes or no? Yes or no? Right? So, x cube into dx will become dt by 4. So, integral of sine x power 4 x cube dx Okay, so this will become sine x power 4 is t and x cube dx is dt by 4. Now integrate. Integration of sine is what? Minus cos. So minus cos t upon 4. Let's not forget that you have to remove t and replace it with x power 4. So you are going to get this as your final answer. Okay, all right, clear. Let me know your answers in the chat box. Got it, got it. Give me a big thumbs up. Yes, Kush Mohit, but you are a little late. This time, you're a little late. Okay, is it very tough? Is it tough? Is it a little on tougher side? What do you think? I think it's easy. I don't think it's tough. Okay. Whatever we are learning the technique, we are applying it directly. We are doing nothing new. It's nothing tricky in that. Okay. The questions are not that tricky this time because we are learning. If we are in learning phase, gradually I'll increase the level. Okay. Yes, Akash. Second option. Absolutely right. Okay. Now some more formula. Some more formula. Can anybody tell me integration of tan x? Integration of tan x dx will be what? Log of mod of sec x plus c. This is the formula. Now let's talk about the proof, like how we are getting log of mod of sec x. Okay. So now tan x, I'll be writing it as sin x upon cos x dx integral. Now if I substitute cos x as t, put cos x is equals to t. So minus sin x dx becomes dt. Correct? Sin x dx will become minus dt and cos x will be t, and this is going to become minus of log of mod t plus c, because the integration of 1 by t is what? Log of mod t, right? So this is going to become minus log of mod of, this is going to become what? T. T. What is t? What is t? Cos x plus c, right? Now you know that minus log of anything, let's say alpha, is equals to log of alpha power minus 1. You know this property, right? So this minus 1 will be on the power of cos x. So log of mod of cos x power minus 1 plus c, and cos x power minus 1 means reciprocal of minus 1, my dear students. Reciprocal of cos x. Reciprocal of cos x is log of mod of sec x plus c. So here we are getting the result. Is it okay? Is it cool? Okay. Now the integration of tan x is what? Log of mod of sec x. Okay, ma'am, clear. Now on a similar line, I will give you another formula, which is integration of what? Cot x dx. Okay. So integration of cot x dx is going to become log of mod of sin x plus c. And the proof to this, now the similar proof is similar. Cos x upon sin x. Cot can be written down as cos x by sin x, and sin x you have to put equal to t, and then rest will be your thing. Okay. So this time the proof will be homework. I am not giving you proof. The similar proof you have to do it on your own, guys. Okay. Now you can do this. Okay. You're not small children, small kids. Okay. Now one more formula I would like to give you. Integration of sec x. Integration of sec x dx. Now this is very important and the proof is also important. So I'll give you this proof. Can anybody tell me how to solve it? Can anybody think about it? Or anybody know the technique, or anybody know that exactly how to do it? Yes? Tell me. Can anybody tell me that how to solve it? Okay, by the way, I'll give you the direct formula also. Integration of sec x dx is log of sec x plus tan x plus c. Okay. So what I'll be doing is, let me tell you, in your second PUC, this can come as a direct question that prove it or find it. Okay. How to prove it? What is so special about it? What is why Ninja Ma'am is giving so much stress on this proof? Because it is not that easy. Sec x, in it, what I'm going to do is, I'm going to multiply and divide by sec x plus tan x. So sec x plus tan x. Okay. So sometimes you have to do some manipulation. Sec x plus tan x upon sec x plus tan x. Correct? Integration dx. Now multiply it inside. The moment you start multiplying, it is sec square x plus sec x tan x. Okay, upon sec x plus tan x. And this is your dx. Correct? Now again, substitution will come into the picture. What I'm going to do is, I am going to substitute sec x plus tan x as t. Sec x plus tan x as t. And now you'll be like, okay, what has just happened? I want your maximum attention over here. Sec x plus tan x. This thing I have substituted as t. Derivative of sec x is what? Ma'am, sec x tan x. Derivative of tan x is what? Ma'am, sec square x. With respect to dx equals to dt. Can you see this? Are you serious? That the moment I have taken sec x plus tan x as t, the derivative of this is rightly present over here in the numerator, guys. Right? Yes, if this is t, this is nothing but its derivative. That is, this is dt. Can you see? So this is clearly dt upon t, guys. Okay. And integration of 1 by t is what? Log of mod of t plus c. What is t? So this is log of mod of sec x plus tan x plus c. Okay. All right. Yes. Now also one more thing that this is also equal to, let me tell you, your integration of sec x is also equal to one more expression, which is log of mod of tan of pi by 4 plus x plus constant. Okay, pi by 4 plus x by 2 plus constant. Okay, so now sometimes it happens that they directly give you this. So it's very important that you understand that sec x plus tan x can also be written down as tan pi by 4 plus x by 2. I'll show you this. Okay, so sec x plus tan x. Let us solve sec x plus tan x. Okay, sec x plus tan x, correct? Now sec x plus tan x will be 1 upon cos x plus sin x upon cos x, correct? And now if you take LCM, what will you do? 1 plus sin x upon cos x, correct? Now 1 plus sin x, understand, 1 can be written down as sin square x by 2 plus cos square x by 2. Yes, this 1 is sin square x by 2 plus cos square x by 2, and this sin x can be written down as 2 sin x by 2 cos x by 2 upon cos x is what? Cos square x by 2 minus sin square x by 2, correct or not? And now the numerator is a square plus b square plus 2ab. So sin x by 2 plus cos x by 2 and whole square upon cos a square minus b square, cos x by 2 minus sin x by 2, a minus b, a plus b, correct? So this is going to get cancelled out with this, and can you see sin x by 2 plus cos x by 2 upon cos x by 2 minus sin x by 2. So here what you have to do is divide the numerator and denominator both by cos x by 2. Okay. Alright. So divide both numerator and denominator by cos x by 2. So cos x by 2, cos x by 2, cos x by 2, cos x by 2. Okay. So this is going to give you 1 plus tan x by 2 upon 1 minus tan x by 2. And this is back to what? Tan of pi by 4 plus x by 2. Okay. So just I was telling you the equivalent expression of sec x plus tan x is what? Tan pi by 2 plus x by 2. This is pure trigonometry, guys. This is not even integration. Abhishek R, okay, you want to watch it recorded? Cool. Okay. All right. Okay. So now this is it. Now another formula. See, integration of sec x we saw. Now we are going to see integration of what? Cosec x. Okay. So integration of cosec x is log of mod of cosec x minus cot x. Same. You have to multiply. Now to solve this, to give you a proof, you will find this proof in your books and even in NCERT also, that to integrate this cos x, you have to multiply and divide with cos x minus cot x. The moment you will multiply, divide, put the denominator is equals to t, you will get the numerator as dt, so log of mod of cos x minus cot x. Okay. So this will be your homework. Yes, you will be able to do that. Just like previous thing, just like integration of sec x, this is going to be on a similar note. Okay. So either this or this is also equivalent to minus log of cosec x plus cot x. Okay. I hope that you are getting the integration part of it, that this expression is logically equivalent to minus log of cosec x plus cot x, or it is log of mod of tan x by 2 plus c. Okay. Alright. So you just prove it this and then try to convert this into all three other expressions. Okay. Alright. This is it. Now I will be talking about some rules of integration. Okay, enough about formulas. So many formulas I have given it today. One step at a time, because in integration you also know there are so many formulas. Okay, so whatever formulas I am giving you in this lecture, you should be able to remember all those formula right now, today itself. Okay, you can't be waiting for like next turn that okay, I'll be doing it in next week or the next to next week. Don't do that. Don't procrastinate. Okay. Alright, so now I'll be giving you rules of integration. Rules of integration. So, suppose you have to integrate a constant f of x dx. So, this constant can come out. This is going to become k integration fx dx. Very easy. Plus c. Okay, sorry. dx. So k, the constant part, you can take it out. This is the very first rule. I guess so many of us are already aware about this rule, that taking constant out. Second rule is, if you are having sum of multiple function, for example f1x plus minus f2x plus minus f3x and so on with respect to dx. So what you can do is, you can integrate it one by one. Integral of f1x dx plus minus integral of f2x dx plus minus integral of f3x dx and so on, all the way up to it will go. Okay. Alright. So based on these formulas which we have studied in this lecture, based on these rules which we have studied in this lecture, I have got a few problems for you. Okay. So the problems are, first problem is very basic problem. Let us see how many of you are able to pull it off. 4x power 5 plus root x with respect to dx is what? Okay, integrate. Very first question, guys. Are you doing it? Till the time you try it, I'll experiment with the color. Okay, which color should I write with? I think this color. Okay. Yeah. Let's integrate. So obviously function 1 plus function 2. So 4x power 5 integration with respect to dx plus root x dx. Again integration. This is going to become 4x power 5. Integration of x power 5 is what? X power 6 upon 6 plus integration of root x. So integration of x power half is what? X power half plus 1 upon half plus 1 plus c. So this is going to become 2 by 3 x power 6 plus this is x power 3 by 2 upon 3 by 2. So this is 3 and this is 2 plus constant. This is your final answer of the integration. Easy question. What do you think? Shall I increase a level a little bit? Shall I give you a little bit tougher question? Or shall I give you one more easy question, then switch over to the tough question? What do you think, guys? Okay. So, second, 2 raised to power x minus 3 raised to power x upon 5 raised to power x integration with respect to dx. Let us see how many of you are able to do it. Okay. Obviously, the formula is a raised to power x integration is what? A raised to power x upon log of a plus constant, right? Okay. So 2 by 5 raised to power x minus 3 by 5 raised to power x dx. I can do this also, right? Now 2 by 5 is a raised to power x. Integration of this is 2 by 5 raised to power x log of 2 by 5 minus 3 by 5 raised to power x raised to power log of 3 by 5 plus constant of integration. This is your final answer. Yes? Getting it? Little? Yes? Okay. Alright. Okay. So now with me, I have a very good question for you. I guess we are done with the basics. Now it's the time that you should prove it to me that, ma'am, yes, we are getting it. We are getting whatever you are teaching us, okay? Now is the time. Shall I write the question? So the question is dx upon cos x plus root 3 sin x. Okay. Option A, B, C and D. Okay. So this is 1 by 2 ln mod of tan x by 2 plus pi by 12 plus constant of integration. Option A. Okay. Then it is 1 by 2 log of mod of x by 2 minus log of mod of tan of x by 2 minus pi by 12 plus c. C option is where there is no 1 by 2, is just pure log tan of x by 2 plus pi by 12 plus c. Option D, log of mod of tan of x by 2 minus pi by 12 plus c. Okay. Yes, Prashant Patil. Chalo. Let's see how many of you are able to do this. Okay, so first of all, remember I told you, let's see how many of you were watching my lecture like very nicely, very attentively. I told you multiple times, and I tell this in every session of my integration session, that sometimes, or you can say majority of the times, the integration problem is not about integration, my dear students. The integration problem is all about simplification first. This integration problem will barely need any integration overall, but it will test your simplification skills. In the last, there will be a small formula which will be used. Are you getting my point? I'll show you, okay? So cos x plus root 3 sin x, okay? This is your expression. Now what I'm going to do is cos x plus root 3 sin x. I am going to simplify this a bit. How will you simplify it? I don't know how many of you are good at trigonometry, but the moment you see any expression which is of the type a cos x plus b sin x, right away multiply and divide with square root of a square plus b square. You have to multiply and divide with square root of a square and b square, guys. And you're done with it. So cos x root 3 sin x. What is this? This is root 4, which is 2. So you have to multiply and divide with 2 and 2. So 2 we are multiplying. Okay, let me change the color. Okay. So I am just, it is not changed or what? So 2 I am multiplying. 2 I am multiplying, 2 I am dividing. Okay. So 2 will stay here, and this is cos x into 1 by 2 plus this is root 3 by 2 sin x. Correct? 1 by 2 over here will be nothing but cos 60 degree, which is cos pi by 6, or you can say sin pi by 6, right? Sin pi by 6. 1 by 2 is sin 30 degree, sin pi by 6. And this is cos pi by 6, correct? So whole expression now has become 2 sin pi by 6 cos x plus cos pi by 6 sin x. Can you see 2 sin a cos b plus cos a sin b is sin a plus b or sin b plus a. So this whole expression is becoming 1 upon 2. Sin is what? Cosec. So cosec x plus pi by 6 plus c. Yes or no? Okay. Alright. So just cos x plus root 3 sin x has become this. So I have replaced this. 2 sin cosec x plus pi by 6. Sorry, 2 sin x plus pi by 6 will become what? Cosec x plus pi by 6 plus c. Yes or no? Now integration of cos x is what? Tell me. Integration of cos x, who is tell me? So 1 by 2 is right here. Integration of cos x is log of, mod of, tan of. Now tan of pi by 4 plus, okay, so it is going to become tan of what? Pi by 4 plus x by 2, right? Pi by 4. Hold on. Integration of cosec x was what? Tell me. Integration of cosec. So it is log of tan x by 2. Yes. Can you see this formula? Log of mod of tan x by 2. So yes, this formula I am going to apply right here. Log of mod of tan x by 2. That means this upon 2. So x upon 2 plus pi by 6 upon 2 is pi by 12. So this is pi by 12. Plus c. Can you see half is already there, plus sign? Option A is absolutely right. Yes, have a look. Let me know in case of any doubts and any issues. Have a look. What do you think about this problem? Good, easy, bad, not good? Tell me. Okay. Hi Prabhu, how are you? Okay, so I guess we are done with this problem. I guess you guys are like getting the idea of this. Okay. Now we are moving towards the next technique, which is going to be integrals of the form. Not so good, but not so good, not so bad, but tricky. Okay, Kushmohit is reviewing this problem, huh? Kushmohit, now you started reviewing the problems as well. Good job. Okay, so integration of f of ax plus b, right? So we are going to talk about this form, which is integration of f of ax plus b, right? Okay. So whenever you get such a question, what you have to do is, so this is your question, integration of f of a of x plus b, okay. So what I'm going to do is ax plus b, I'll be putting it as t. So a dx will be equals to dt, correct? So now let us convert this. F of ax plus b is t. Dx will be replaced by dt upon a. So this is dt upon a, right? So very easy, you just have to like integrate this. So this is integration of f of ax plus b, okay, or you can just directly write it as f of t upon a plus c, where t will be replaced by capital F. Integration of small f is capital F. So this is ax plus b upon a plus b. Very important. Understand what we are trying to do. Understand what has happened over here. So if you have to integrate any function which is having ax plus b, this ax plus b will be differentiated in the numerator. Can you see this? I'll show you. Wait. I'll show you with the help of the example. One example I would like to give you, okay? Let's just apply it. So, suppose ax plus b power n you have to integrate, right? So, the answer will be integration of ax plus b general. So, x power n integration is what? X power n plus 1 upon n plus 1. So, same. Ax plus b power n plus 1 upon n plus 1, but this ax plus b will be differentiated in the denominator so that it will become ax plus b derivative is a plus constant of integration. One more question so that you understand this better. E raised to power ax plus b dx integration is what? So ma'am, e raised to power x integration is e raised to power x. So this is going to be e raised to power ax plus b, but in the denominator, you have to differentiate ax plus b. So this is how it is going to become. Okay. Alright. Now 1 upon ax plus b integration with respect to dx. Okay. So if you integrate this 1 upon ax plus b, it is going to become log of mod of ax plus b plus constant of integration. But don't forget that there will be 1 by a over here, right? Okay. And now if you are having a raised to power bx plus c integration with respect to dx. So again, a raised to power bx plus c will be a raised to power bx plus c upon log of a, and this time bx plus p will be differentiated in the denominator, so that is going to be b plus constant of integration. Are you understanding this? Give me a big thumbs up if you understand the format. Okay, if the format is like crystal clear for you. Okay, so I'll give you some more formulas on the similar note. Okay. All right. Now, integration of cos of ax plus b dx. integration of sine of ax plus b with respect to dx, integration of sec square ax plus b with respect to dx, integration of cosec square x ax plus b with respect to dx, integration of sec ax plus b with respect to dx. Okay, all right. So integration of cos is what? Ma'am, integration of cos is sine. So just sine ax plus b. Let's not forget upon a. This is minus cos ax plus b upon a plus c. Integration of sec square is what? Tan. So this is tan ax plus b, right, upon a plus c. Integration of cosec square x will be what? Minus 1 by a cot of ax plus b plus c. Integration of sec is what? Integration of sec, integration of not sec, but integration of sec x tan x. So this is, this is tan ax plus b plus a dx. So this is what? So differentiation of sec x is what? Sec x tan x. Integration of sec x tan x is what? Sec x. So this is sec of ax plus b upon a plus c. Similar format, so many formulas. Yes, Kush Mohit, absolutely correct. You are killing it, Kush Mohit. Okay, especially for these formulas. Okay, now let's just do a problem on this. Let's do a problem on this. Integration of 3x plus 4 minus tan x plus 4, tan x upon 4 and dx. Let's see how many of you are able to do it. Let's see how many of you are able to do it. Okay, this is the problem. So it is very easy. 2 raised to power 3x plus 4, correct? So the integration of a raised to power x is what? Log of, this is a raised to power x upon log a plus c, correct? This is the formula. Let's use it. 2 raised to power 3x plus 4. So 2 raised to power 3x plus 4 upon log of 2 is there. But 3x plus 4 will be differentiated in the denominator. So this is 3. 2x plus 4 3x plus 4 is what? Derivative of this is 3, correct? Minus. Now derivative of tan is what? So derivative of tan is log of sec. So log of sec x. So log of mod of sec x by 4. And understand, now this expression is what? Of the form, it is not x. It is of the form ax plus b. So now x by 4 will be differentiated in the denominator so that it will give me 1 by 4. So what will be the final answer? Tell me. So this is 2 raised to power 3x plus 4 upon 3 ln 2 minus 4 log of mod of sec x upon 4 mod plus constant of integration, guys. Constant of integration. Yes? Getting it clear? Absolutely perfect. Okay. Some more questions? Are we good? Are we okay? Is it like, are we finding it very difficult? Like, are we getting the hype about integration in the market, in social media is too much? Kush Mohit. Kush Mohit is saying, I got the same answer. Okay, so hype about integration is like so much. You will get a lot of memes wherein integration is so tough, integration is something else, somebody is talking from the next world. But if you understand this nicely, gradually, step by step, trust me, you will be like, integration is my most favorite chapter. Okay, all right. So yes, that's how it is. Okay, now I'll be giving you one more question, that is integration of sine square x dx. Now, how will we solve it? Do we have a formula for it? Or in fact, do we even want a formula for this? No. So basically, I have two formulas for you, two trigonometric formulas I would like to remind you. First one is 2 sine square x. Second one is 2 cos square x. Do you guys remember? 2 sine square x is 1 minus cos 2x. And 2 cos square x is 1 plus cos 2x. I call this as two gold formulas. Gold formulas. Okay. So whenever you have to integrate sine square x or cos square x or even sine cube or cos cube, use the formula which convert your square to multiple angles. Right? So sine square x will be what? 1 minus cos 2x. Integration dx. Correct? Integration of 1 is what? X. Integration of cos is what? Sine. But this 2x will be differentiated in the denominator. Plus c. This will be your answer. Done, 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 done. Easy peasy lemon squeezy. Yes. Okay. Second question I would like to give you directly right here. Integration of cos square x. This is a homework, like this is do DIY. I will not help you. DIY. Right here you just do it. Let me know your answer in the chat box. Quickly, this question. Same answer. What about this? Cos square x dx. Obviously, it will be 1 plus cos 2x. The only difference between this and this will be, the answer will be x plus sine 2x upon 2 plus c. Yes or no? This is what you're going to get. Okay. Shall we move on to the next category, next type? So, the moment you will have a question of course, trigonometry, like multiplication or product of sine and cos, just like this, cos x sine 3x. Now what will you do? There is a product. We don't have any product rule. Till now we have not studied any product rule. Can we do it? Understand. So what I'll be doing is I'll be converting the product into sum. Can I do that? Do you remember that formula? 2 cos a sine b. 2 cos, or you can just say 2 sine a cos b. 2 sine a cos b. Can anybody help me with this formula? 2 sine a cos b. This is going to become sine a plus b plus sine a minus b. Yes or no? So again, what I'm going to do is, I am going to multiply 2 and 2. So that 2, this is 2 sine 3x cos x dx, and this is 1 upon 2. 1 by 2. 2 sine 3x cos x, right? So 2 sine a cos b is sine a plus b, that is 4x, plus sine a minus b, that is 2x. Okay, so I already told you, majority of the questions will not test you on your integration skills. Trust me, till now I have not used integration in this. I am just doing simplification. Everything is all about simplification in integration chapter. Are you understanding it? So if you are not good at the previous chapter, especially trigonometry, then you will not be good at this. Okay. Now integration of sine is what? Minus cos 4x upon 4 minus cos 2x upon 2. Let's not forget, there is already a half over here, plus constant. So finally, minus cos 4x upon 8 minus cos 2x upon 4 plus constant of integration. Yes? Clear? Give me a big thumbs up if you are okay with this. Yes? Next question. Next question. Okay, so this is a question. Next question. Okay, next question says integration of dx upon square root minus square root. Square root is having 2x plus 3 and 2x plus 4. Sorry, 2. Integrate. Integrate, guys. And also, if you have not liked the session, then though I'll be not talking about it. Do like the session, guys. Do like the session. Okay, you know that you have to like the session and share the session with your fellow KCET aspirants. Okay, so yes, now again, integration will be barely used in the last step. We just have to rationalize this expression. Integration of 1 upon square root minus square root. This is 2x plus 3. This is 2x plus 2, correct? Multiply square root 2x plus 3 plus, plus, yes, 2x plus 2 upon square root 2x plus 3, 2x plus 2, right? So a minus b, a plus b. So a square, 2x plus 3 minus 2x plus 2, and this is square root of 2x plus 3 plus square root of 2x plus 2, and this is also dx is already there, na? Dx integration. So understand, 2x cancel, 3 minus 2 is 1. So this is 1. 2x plus 3, so this is root of 2x plus 3 plus root of 2x plus 2 integration with respect to dx. Right? So now till now just simplification we have done, and now is the time 2x plus 3 power half plus 2x plus 2 power half. Integration with respect to dx, Okay. So integration of, remember what is this? Ax plus b form. Don't forget ax plus b form. So x raised to power n integration is what? 2x plus 3 raised to power half plus 1 is 3 by 2 upon 3 by 2. But don't forget, 2x plus 3 will be differentiated in the denominator. This is something which most of the students forget. You do not forget, because you are a Ninja Ma'am student, right? You have no other option. You have to do it. Plus 2x plus 2 raised to power 3 by 2, and this is 3 by 2, and again this is 2. Correct? 2 cancel. So this is 1 upon 3. 2x plus 3 power 3 by 2 plus 2x plus 2 power 3 by 2 plus constant of integration. Have a look. Let me know if you have understood everything in this question. Okay? Clear? Okay. All right. Now one more question to test your skill set. Okay. That whether you are good at the manipulation or not. Let's see how many of you are good at manipulation. This question only those students will be able to do when they are good at manipulation skills. Now, ma'am, what is that manipulation skills you always talk about, or you're talking about right now? Manipulation skills means that just add something, subtract something to make it work, okay? So if somebody notices, okay, x cube is in the numerator, but x minus 1 is in the denominator. So what if I somehow get x minus 1 in numerator as well? What should I add? What should I subtract? Okay, so very few students are able to think about adding and subtracting something. Are you getting my point? But you know what, one or two times if you understand that, okay, here we have to subtract, here we have to add, you'll be absolutely in that category of good manipulation skills. Okay, so yeah, in this question, what I'm going to do is I'm going to subtract 1 and add 1 upon x minus 1 will be as it is. Okay, because I want my x cube minus 1 together. X cube minus 1 will be a cube minus b cube. A cube minus b cube is a minus b, a square plus a plus b. Plus 1 is already on the right hand side. This is upon x minus 1 upon x minus 1 integration dx dx. So what I did is I kept this together and 1 on the other side and then separate it out. This is separate thing, this is separate thing. X minus 1 is getting cancelled out. So integration of x square plus x plus 1. Now this is so very easy. Individually integration of x square you know, x you know, integration of 1 you know, and this is integration of mod of x, so 1 upon x minus 1 dx. So this is integration as log. So final answer will be x cube by 3 plus x square by 2 plus x plus, this is log of mod of x minus 1 plus constant. Okay? Clear? All right. Yes. Okay. Now one last question, or I would say two more questions. Let's do two more questions. What do you think? So by 8:30 we'll be finishing our class. Then 9 o'clock you have Shreyas sir's class. Okay. So half an hour break is fine. What do you think? Let's finish the substitution part altogether. Okay. So the question says e raised to power m tan, okay, no, this is inverse. Okay, inverse I cannot give. Sorry guys, this I cannot give. So only one question I have then on my plate, which is 5 raised to power, okay, 5 raised to power 5 raised to power 5 raised to power x. 5 raised to power 5 raised to power 5 raised to power x. Then 5 raised to power 5 raised to power x. Then 5 raised to power x dx. Integration. This is your question, guys. Okay. And I have options also. This is the last question, by the way. Okay. Options are 5 raised to power 5 raised to power x upon ln 5 ka cube plus c. Okay, then we have 5 raised to power 5 raised to power 5 raised to power x upon ln 5 whole cube plus c. Option C is 5 raised to power 5 raised to power 5 raised to power x into ln 5 cube plus c, and option D is 5 power x into ln 5 whole cube plus c. Let's see how many of you are able to do that. Okay, this is the last question, my dear students. Do it diligently, okay? Maximum effort I want to see. All right, okay. So, okay, let us solve it out. Are we ready for the solution? Okay. So in this question, what I am going to do is, I am going to take this 5 raised to power x equals to t. Okay? 5 raised to power x will be t. Okay? And so this is what? 5 raised to power t. Correct? This will be 5 raised to power t. Right? So now 5 raised to power t can be taken out as a. So now the question will become, understand, this is integral of 5 raised to power, now 5 raised to power x is what? T. So this is 5 raised to power t. Now 5 raised to power a, this will also always be replaced by a. Can you see? This is your 5 raised to power a. Okay. Now differentiate this. So what will you get is 5 raised to power x and ln 5 dx is equals to dt. So dx will be what? Dx will be 5 raised to power x into dx. See, 5 raised to power x into dx will be replaced by dt upon ln 5. dt upon ln 5. But can you see here, this is a, not t. So now this is also we have to differentiate. So 5 raised to power t ln 5 dt will be equals to dA. Correct? So 5 raised to power t, this is what? Understand. This is your again 5 raised to power t. So 5 raised to power t into dt. 5 raised to power t into dt will be dA upon ln 5. So 5 raised to power a, dA upon 1 more ln 5. So this is ln 5 whole square. Now integration of 5 raised to power a, who will tell me? Integration of 5 raised to power a is 5 raised to power a upon ln 5. And there are 2 more ln 5, that is why it is a cube plus constant c. 5 raised to power a is what? 5 raised to power 5 raised to power t. T is what? 5 raised to power x. So this is what your final answer looks like. 555x, 555x, and in the denominator ln 5 whole cube. Yes or no? Yes or no? Okay. So by this question, we are in the end of the session, and I'm just checking whether I have any homework question for you guys. No, I guess no homework today. And PDF will be shared in the Telegram. Make sure you're subscribed to Karnataka channel Telegram, and make sure you're subscribed to my Telegram as well, t.me/Namrata Jaisinghani. Okay. And the Telegram link is already in the description box. You just click it, you'll get it. Okay. So now I guess you will have a like half an hour break, more than half an hour. 9 o'clock, Shreyas sir will be taking the session. And this is me, your Ninja Ma'am, signing off, and I'll see you all in the next video of integration. So make sure that you're understanding, you're attending all the sessions of integration serial wise, okay? Bye bye, see you.